Hello everyone. Welcome to a new video where we will again talk about AI agents applied to energy efficiency. This will be our second video in our series. Before we get started, I'd like to make sure you have a general idea about multi-agent systems, or if you'd rather we start from the basics.
I have read some of it, but I would appreciate it if you could start with an introduction. I want to understand what they are and how they can help us.
Sure, let's cut to the chase. Multi-agent systems, or MAS, are a branch of artificial intelligence that allows multiple autonomous agents to work together in a shared environment. An agent is an entity that can be software, a robot, or even a system that makes decisions independently to meet certain objectives.
Interesting. So, do these agents always work as a team?
Not necessarily. For example, in a smart grid, one agent might optimize renewable energy generation, while another might manage household consumption. The two could cooperate to balance supply and demand, but they could also compete for limited resources.
Understood. And how is an SMA organized in energy?
Good question. These systems have a multi-tier architecture. For example, at the local level, an agent could manage the energy consumption of a building. At the community level, agents coordinate several microgrids, and at the global level, they monitor the entire grid. Each agent has defined roles, such as monitoring power generators, managing batteries, or facilitating transactions in the energy market.
It looks very sophisticated. What are the advantages of using this?
Many. For example, SMAs are decentralized, meaning that they do not rely on centralized control. This increases the resilience of the system. They are also scalable, allowing new agents to be added without disrupting operations. In addition, their autonomy and flexibility make them ideal for changing environments, such as integrating renewable energy efficiently.
It looks promising. But are there practical cases that demonstrate its effectiveness?
Of course, take smart buildings as an example. SMAs can automate HVAC systems, adjust lighting according to occupancy, and detect equipment failures before serious problems occur. In industry, they help optimize production processes and coordinate robots in warehouses. And in renewable energies, they manage wind and solar farms, optimizing their operation according to weather conditions.
And what is the role of distributed intelligence here?
Excellent point. Distributed intelligence allows each agent to make decisions based on local information, but working in a coordinated manner for a global objective. For example, in smart grids, agents optimize energy flow and anticipate demand peaks. This improves efficiency, reduces losses, and makes the system more sustainable.
This sounds ideal, but what about the challenges?
I'm not going to lie to you, there are significant challenges. For example, ensuring interoperability between agents developed by different companies, cybersecurity, and complying with local energy regulations. However, these issues can be mitigated with good planning and the use of appropriate standards.
Very clear. Finally, how would we start implementing something like this in my company?
The first step would be to identify your specific needs and define which agents would be required. Then, we could design an architecture that can grow with you, starting with small pilots to test the benefits before a full implementation. Would you like us to prepare an initial roadmap?
Yes, definitely. This sounds like a great step towards modernizing our operations. Who would I need to contact to move forward?
Perfect. Let's work together to make it happen. I assure you that the impact will be transformational. You can contact our expert Antonio Fresco Navacerrada via LinkedIn. He will guide you through the process. Thank you for watching this video, and don't forget to subscribe to be more informed about how artificial intelligence can revolutionize the energy efficiency of companies.